In this video, we're going to do some problem solving with the fundamental trig identities that we've learned. So we're going to be given that sine of 30 degrees is equal to 1/2. And we're going to use trig identities to find the exact value of cosecant of pi over 6. Well, the first thing that we need to do is we need to change 30 degrees to radians because our angle over here that we're finding the cosecant of is in radians. So 30 degrees times pi over 180 degrees is the same thing as pi over 6. So that's good. We can say that sine of pi over 6 radians is 1/2. Now, if I want to find cosecant of pi over 6, that's the reciprocal of sine of pi over 6. So that's the reciprocal of 1/2. So cosecant of pi over 6 is going to be 2 over 1 when I take the reciprocal of 1/2, or 2. Number 38, if we're given that cosine of 30 degrees is equal to √3 over 2, we want to use trig identities to find the sine of 30 degrees. Well, the only relationship that I know from my fundamental trig identities is that sine squared of 30 degrees plus cosine squared of 30 degrees is equal to 1. So sine squared of 30 degrees plus √3 over 2 squared is equal to 1. Sine squared of 30 degrees plus 3/4 is equal to 1, which is 4/4. Sine squared 30 degrees is equal to 4 minus 3 is 1. And sine of 30 degrees is going to be the square root of 1/4 is going to be 1/2, which is exactly what they told us it was in problem number 37. But we needed to find the exact value using our trig identities in number 38. Number 39, given that cotangent of theta is going to be equal to 4, we're going to use trig identities to find secant theta. Well, I don't know a relationship right off the top of my head between cotangent and secant, but I do between tangent and secant. So I'm going to say that that means that tangent of theta is equal to 1/4, and then 1 plus tangent squared is equal to secant squared. So 1 plus 1/4 squared is secant squared. This is 1 over 16, and this is 16 over 16. So this is 17 over 16. I take the square root of both sides, and secant theta is the square root of 17 over 4. Number 40 tells us that the cosecant of theta is 2, and we want to find the value of secant squared. So we're going to have to change that into sine, I believe. So let's do that. If I can change this into sine, then I can say that, let's use my definition here. Here's theta, Here's 1 and here's 2, like so. Let's use the Pythagorean theorem to say that 1 squared plus unknown side squared is equal to 2 squared. Then x squared plus 1 is equal to 4. X squared is equal to 3, and x is equal to the square root of 3. That would make secant theta equal to 2 over the square root of 3, and secant squared would be equal to 4/3. See if there's another way that I could have done that with just identities. Might take me a little longer, but I'll get to the same place. So cosecant squared is going to be 4. And since 1 plus cotangent squared is cosecant squared, then cotangent squared is equal to cosecant squared minus 1. Cotangent squared is equal to 4 minus 1. Cotangent squared is equal to 3. Cotangent is going to be equal to the square root of 3. So actually, let's take this as like so. That let's leave it like that because I want to get to secant squared. So this is tangent squared is going to be 1/3, and 1 plus tangent squared is equal to secant squared. So 1 plus 1/3 is equal to secant squared. And so 3/3 plus 1/3 is what I'm looking for, and secant squared is equal to 4/3. I think that's how the problem was supposed to be done with the identities. Now, given tangent of theta is equal to 2, find the exact value of secant of pi over 2 minus theta. So we're actually going to find cosecant of theta is what we want because this is a co-function identity. So complementary angle and co-function here. So let's find cotangent. Cotangent is 1/2, and 1 plus cotangent squared is equal to cosecant squared. So 1 plus 1/2 squared is cosecant squared. This is 1/4. So let's write that 1 as 4/4. This 5/4 is cosecant squared. So cosecant has to be √5 over 2. And I can go back and write cosecant as secant of pi over 2 minus theta if I would like to. Last one for this section, if cosecant theta is equal to 2, find what cosecant of theta plus secant of 90 degrees minus theta is. It really doesn't matter what cosecant equals in this case. Here for right now, in this first step, because this is cosecant plus cosecant, now I get to make the substitution that this is 2 plus 2. So this is 4. So we had to use our complementary angle theorem at first to get them both in terms of theta. And then they were both equal to cosecant. So I made the substitution for both of them, and 2 plus 2 is 4. Yeah, that's my last problem for this section. So I will see you for the next section of videos. Have a good one.